In this episode, I have an Akai 4000DS Mark II reel-to-reel machine. This one's got a couple problems. One, it has high wound flutter. Two, it's noisy, both mechanically and electrically. So we're going to have to tear this one apart and obviously track down a bad transistor or two that's causing lots of noise in the audio. This one should be a fun one. Let's check it out. I have an Akai 4000DS in for service. Don't know anything about it. Haven't tried it yet. Haven't turned it on. Haven't hooked it up. We're going to see what it does. So I got a tape. What's it say here? Okay, sounds wobbly, wound flutter. Noisy when powered on but not playing. Right spindle is bent and grinds. Okay, that's what the note on this one is. See, this one came in for service. So let's power it up and see what it does. Maybe this is why the thing's got wound flutter. Look at that! Look at that capstan shaft on there. Holy crap! What the hell is this? It's like, that doesn't look like an original Akai capstan shaft, does it? Alright, let's just power this thing up first of all and see what it does. So, power on. It does wobble a bit. I don't know that I can do much about that without damaging it more. It's got torque. The complaint is wound flutter. You think that I can feel the wound and flutter with my finger. This is not any good. Fortunately, I happen to have a 4000 that I can steal an entire pinch roller out of. That's mine, if need be. But I mean, well, here, let's just take a look at this. Watch this. This is to try to illustrate that this is not. See what I mean? Like that is not smooth. No wonder he's getting wound flutter. You can hear it. Yeah, okay. This needs a new capstan shaft. No doubt. But I just may happen to have one for him. If the price is right. Because I have a machine that's mine that the cams are broken on. So I can steal a capstan shaft from that. First sign that this is bad is this is supposed to unscrew so you can put the sleeve over here. In fact, it might not even need the capstan shaft. It might just need the sleeve. Looks like somebody's done a number on this. We'll take off the pinch roller first of all, which probably also needs to be replaced. That way I can at least grip the capstan shaft and see if I can unscrew this. What the hell did someone do? They lost this. The adapter is what they've done. They've tried to make their own. So I might be able to get by with just replacing this adapter because I just so happen that I have the proper adapter for that. You take this off for 3 3/4 and you put it on for 7 1/2. And what's happened is somebody has lost. They tried to machine it themselves. Looks like they turned this on a lathe or something, but they didn't do a very good job. They tried to make their own. Let's put the right one on. So this is the poor excuse that someone tried to make this thing work. This is the proper aluminum capstan shaft. As you can see, it's bigger for one. Look at the difference. But this fits on there. Well, it probably doesn't anymore because somebody's buggered it up, but this fits onto here, and then this screw goes on. And we won't have any of that. It'll just be nice and smooth now. Right? Unlike the last one, which was he'd put this collar on there because it wasn't big enough, and then screwed this on the end of it. And you wonder why it was sounding as bad as it was. We'll do this again. Listen to this. Yeah. We can do it before and after. Let's do that. I'll just put that on there. That's where you normally store that, right? So when you're playing 3 3/4 tapes, you take it off and put it on there so that it runs at 3 3/4 instead of 7.5, because this was a single speed machine. But we'll see how it sounds. I just want to see the difference in the sound. This pinch roller probably is okay, but we'll try it out. We'll thread up a tape and see how bad it sounds. I'll put my tone tape on so we can see how bad it sounds. It's gonna sound terrible with this. All right, are we ready to hear how bad this sounds? Oh, that sounds bad. That's the, what's that, 4 kilohertz, I think? Yeah, 4 kilohertz. Okay, let's put the right one on. We got noisy amplifiers on this too. Really noisy amplifiers. Yikes. Noisy transistors. Yeah, noisy with powered on and not playing. Oh, that's the noise. I like this. For users of magnetic tape. What else would you use a 5 3/4 inch plastic spool for? Like, really? For users of magnetic tape. Well, that's got that problem solved. The amplifiers are a different beast. That's going to be transistors, probably, in the power amps. These Akais were known for pretty bad transistors. Going to put that on there just so that it doesn't get lost for now. We'll pull the back off this thing and take a look at the electronics. I have to laugh. I see people selling these units on Facebook. I saw one recently that somebody was asking. I think it was $400 or $500 for it. I was thinking to myself, what drugs have they been smoking? I bought one of these units a few years ago. I didn't need it. I already had a bunch of reel-to-reels, but it was a ham flea market and the guy was selling it. He had it sitting on his table all day and nobody was buying it. At the end of the day, I'm looking at, oh, nice little reel-to-reel. Don't really need one. I've got several already. And the guy says, give me 20 or 30 bucks for it. I think it was 30 bucks. It was either 20 or 30 bucks. Anyways, he just said, give me 30 bucks and you can have it. He had it sitting on his table. I think he was asking 100 bucks and then he marked it down to 50 and still had no bites. And at the end of the day, he said to me, just give me 30 bucks for it and you can have it. So I thought, you know what? For 30 bucks, I'll take it. And it's been good. All I had to do was clean the controls on mine. The transistors are fine. I don't use it. I use it just for transcribing the odd tape. I've got I got a GX260 as well, which I never use. And I got a couple Sonys and a TIAC, none of which I use. But I figure, what the heck? It's cheap enough, I'll buy it. And I've used it a couple times. Mainly when I have to transfer a tape over to digital. I have a bunch of tapes that were my dad's. It would have been his style of music, which is easy listening, from back in the 1960s. And probably some big band, and well, I know he's got some big band and some jazz and stuff. But he recorded them all at 3 3/4 IPS, so the sound quality isn't as good as it should have been. So I figure someday I'll get around to transferring all those tapes over to digital, and I might come in handy for that. And I've used it a couple times, but again, it's not something I use every day. So this has got our amplifier board on the bottom here. I'm going to flip out the amplifier board, and we'll put the scope on it and just see where that noise is coming from. It's going to be noisy transistors. So this is the bias board, I believe. That one is the bias board for recording. Now you got your record amplifier, left and right record, and left and right playback. So basically 4 separate amplifiers on here, each with their own separate control. Should be able to lift the board out. I think the board will lift out on this one without too much issue. Some of these ones are a real pain to get at, but pretty sure this one here, just a couple screws, and the board will flip out. So it can be inspected. Of course, the real pain in the ass on these is everything's soldered down. There's no plugs, which is good and bad. Plugs cause problems because plugs go bad, but they make it easy to remove the board when you want to work on it. This one here, it's tied down to the rest of the circuit, so you got to kind of work on it with it hanging off the back. As I say, it's a double-edged sword, because you don't have to worry about connectors causing problems with this style, because the entire board just flips down. But here's our board, and could be transistors too, but typically, you get one transistor, you'll get noise on one channel, not the other. This has got noise on both channels. Now, one thing that can cause noise on this has got a sound on sound switch right here, and sometimes this switch, which is that one there, can get noisy. You can hear all that racket, and I'm just going to give this switch a shot of cleaner before I tear into anything else. I've operated it a few times. Let's see if it'll quieten down. There's also the head switch up front here that gives trouble. So we're going to clean all the switches up on it first. There's a switch right here. There's also a record play switch, but that just normally turns on the record amplifiers. Record head and play head both feel to be in good shape. There's no wear that I can feel that you can hook your fingernail on. Tracking down noise problems is a little easier if you use your scope. And you can look at the transistors and see where the noise is being introduced. That'll give you an idea what stage the noise is coming in to the circuit at. I've got noise on both channels, so I'm just going to look on my scope and see if I can see any noise that's being introduced somewhere along the line. There, you see, there's noise there. And there's no noise there. It's a good chance it's that transistor right there. This is where the noise is coming from. Very good chance that this transistor here is bad. As you see, we can look on the scope and we can see the noise. And if I touch the circuit, you see, that's the hum that I'm introducing into that transistor. That's me. But on the transistor itself, there's noise. Another way you can quite often identify bad transistors is by heating and cooling them. So, for example, I suspect it might be one of these ones. So if I heat it up, see if the noise increases. You can also use cold spray on them. So I use my soldering iron to heat it up. Where is it here? This one here. I think it might be this one. Either this one or this one here. Thermally shock them. See if the noise gets louder as we heat it up. Or we can shock them with cold spray. You buy a cold spray, or you can use super duster and just invert the can. And then when you hit the transistor with the cold spray, if you hear the noise change, it's a good chance that's the one that's at fault. So you heard a thump when I hit that one. What about this one down here? There, you see? Now this channel's getting noisy. I believe it's this one here. This one and that one. I think those are the two that are giving us our trouble. You can hear all the noise coming in on the left channel now, if you can hear it, when I cool this transistor down. We'll heat that one up. See if the noise goes away. noise has gone away on that channel. We'll go this side. Do the inverted can again. We'll listen to the left channel here. Another noise coming up. And the equivalent on the other channel was, I think it was this one. Was it this one? Oh, wait a minute, was this one up here? There we go. That one. So usually the way you can isolate these transistors that are getting noisy is just spray some cold spray on them a little bit and see if they get noisy, or they can get quiet. And there. I think it's this one and this one up here, I think, are the two that are giving me trouble. We'll try changing these ones. They're equivalent to an NTE85. I'm sure I can find something that's equivalent to that. I got a couple of others I can replace here. I gotta change the basing on them because the original ones are ECB and these are EBC, so I gotta switch two of the leads around. I gotta put them in more like this. E, C, B. Gotta go in more like that. But we'll try these ones and just see whether I can quieten this thing down. Okay, I got the transistor in. I kind of had to shoehorn it in here because it doesn't fit. Well, it's a different basing, so it kind of turned sideways. And you guys can't see what I did there, but here it is. It's turned sideways. Let's listen to the left channel by itself. I haven't changed the right channel yet, so the right channel I've got shut off. Left channel's on. Amplifier's turned on. There's no hiss. And we got sound. If I go to the right channel's still hissing. Let's change the right channel now. That's fixed the left channel. That transistor there. So let's do the same one on the right channel, which one was it? It was this one here. Where was it? This one right here. So let's change this one out as well. Looks like these might be Hitachi transistors. That would explain a lot because Hitachi made terrible transistors. So I got to do the same for this other one. I'll put the same number in it. So I'm putting in a 123A, which is a pretty standard transistor, an ECG or NTE123A. So there it is there. I'll remove the old one. Get the solder wick in. Try not to get hung up with my soldering iron. See, sometimes even with the best test equipment, the best equipment you can use is a can of cold spray and your soldering iron or heat gun. Heat gun to heat, cold spray to cool it down. Quite often shock these bad transistors into misbehaving. This one's got a bit longer leads. I might be able to sneak this one in. And I had to extend the lead on one of the other ones because the leads are really short. These are transistors were pulls from something else. So it's emitter base collector on this one, and the original was emitter collector base, so I have to change the basing around. I'm going to pick the base pin and just bend it all the way to the back, and I'm just going to stick a wire on it so that I can extend it, and then I can fit it into the board. So I just get a piece of bare wire, solder it to the back onto that lead so they can extend it, and then I can fit it through the board. Now if I had brand new transistor that had full length leads, I wouldn't need to do this, but as I say, I use what I've got, and I've got a bunch of pulls that were pulled out of equipment that was recycled. At least I know that they're not counterfeits and not knockoffs, because these days that's usually what you get when you try to buy a replacement part. You usually get one that's it's a knockoff, right? So at least by utilizing parts that I've pulled out of scrap units that I know are original, that I know I'm not going to get a counterfeit part. Let's look at it that way, right? So the way I extend my lead, so now this is the long one. This becomes emitter, and collectors over here, and then the base goes around to the other side. So we'll bring these leads in line. So that I can insert them into the board. That, and make sure they're going through. Okay, let's plug this one in. Check it now. We've changed the two transistors. Nice and quiet. No noise on the left or the right channel. No noise. Two transistors. It was the same one. That one down there that I changed, and this one right up here. And I had to put in, because the transistor I put in was a different basing. I had to reconfigure it, and I had to extend the wire. You can see on the back of it here, if I can get a shot of it, you can see the transistors I put in. A piece of wire stuck on the back of it, just because I had to reverse the wiring, because the ones I put in, original ones were emitter collector base, and I put in ones that were emitter base collector, so I had to turn them, and because they were used transistors, the leads weren't quite long enough. But that's solved the noise problem. So now I can put this board back together, and actually I can put this unit back together because this one is fixed. Just had to change out the sleeve for the capstan shaft and change two blown transistors, two noisy transistors in the playback circuit. Now I'm sure the record is okay. We'll do a test recording on it, but let me mount the board just so that nothing gets damaged. We'll mount the board, and then I will test it for recording and playback and make sure everything's good. Now a lot of these machines, they used plug-in cards. And some people like the plug-in cards because you can take the boards out to work on them. The downside to the ones with the plug-in boards is, well, the connectors go bad where the boards plug in. That's the downside. Of course, the upside to them is you can pull the board right out and work on it. You don't have to be bending wires back and forth, and eventually if you bend these enough times, obviously they're going to break, so you don't want to twist this thing back and forth too many times. Okay, let me just turn this over. We'll do some test recording on it, see how it works. So here we are, playback. Balance the outputs on here. So I'm just going to put my tone tape on so I can set the levels. The playback gain, basically, and then we'll do a test recording, and that should do it for this one. I'm just checking the balance. Looks like we're pretty close. I'm at like -1 dB. I mean, it's going to fluctuate because this tape is very old. But our levels are pretty much the same for both. So let's load up another tape, make a test recording. Record. And play. We're going to patch the tape deck right into the camera so we can listen to the recording right off tape. All right, I think it's sounding good. I'm not too worried about the, the guy complained about the spindle. I guess he banged the spindle and bent it a bit. I don't want to try to straighten it because I'm afraid I might break. That metal is not very forgiving, and I've seen people that have bent them and they've tried to straighten them out and they've snapped them off. It's not going to hurt anything. It's not so much the spindle. It's actually just the spring-loaded clamp. The table itself is level. It doesn't wobble. It's just the actual end piece here is where it's bent. The metal piece of the shaft that this tape hub, the locking hub goes on, is where the bend is. So that's not going to affect it. I am just checking my tension here. But fast forward and everything works. Good fast forward, good rewind. There's good torque. Good tension on here, that's for sure. I'm just gonna thread it up with a full-size tape. What's squeaking? Oh, that's squeaking. I guess we have to deal with that. Let's get a bird stuck in here. It's chirping. There we go, that's a bit better. I put a larger tape on only because the small little 3-inch reel, the tension tends to be a lot higher on it just because it's a small reel. So that's looking good. Still a mess, shuffle through the same routine. White tee, blue lots of torque. Looking at me back, get myself together, come whatever, just like yesterday. This is something special. Die down with a smile today. I'm gonna give the world a shake. This is a really old tape too. I'm surprised this tape even works. Yeah, I think this one's good. Rewind this tape and throw this one back together. I think we're good to go on this one. It's sounding good. Now I gotta find out what one of these collars is worth so I can sell this one at a fair price. I'm certainly not going to give it away. I'll look up and see what that part goes for. Because I know people lose them and they have to buy new ones, and say I've got a spare just because I've got a spare machine that I'm not going to be fixing, although I could fix that machine. It needs cams. That's what it needs, the new cams. So I could end up fixing it someday, although I really hadn't planned on doing that just because I don't think the machine's worth a heck of a lot of money. The only advantage to that other machine that this came off of is it's one of the few that had Dolby noise reduction, whereas the one that I have doesn't. Not that it matters because I didn't use Dolby on any tapes. None of the reel-to-reel machines that I own have Dolby except for the 4000 Dolby that was given to me. But I say the cams are all shot on it, so I hadn't planned to replace them. And I robbed this off of there. Right, the unit's all back together. Final test. Look at this. Signature binding in 24 karat gold leaf. You put that on here, and then you write on it, and it transfers 24 karat gold leaf onto the tape. I would imagine that this little strip of gold is probably worth a few dollars, being pure gold. And by a few dollars, it's probably worth $2 or $3 in gold, maybe more. I don't know. I don't know how much gold is in there, but it's a strip of it. It's a strip of gold, pure gold. Yeah, it's a strip. Actually, it's quite thick. It's 24 karat gold. What do you know? I got a whole box of these tapes, brand new. Each has got one of those in it. I was given a box of, I think, a dozen brand new tapes that have never been used. And this is, well, I recorded this on it. It's only been recorded on once. That's why this tape sounds as good as it does. It's not worn out. But it's a good sounding Ampex tape. Anyway, this one's done. Thanks for watching. We'll catch you in the next one. Bye.